Hey everyone, my name is Nelson Osacky, and today I'm talking about Dagger Reflect, from runtime to compile time and back again. This is a repeat performance of my talk at droidCon because my talk was so good that someone stole it, so I have to do it again. Alright, so a little bit about me. I've been doing Android for about 9 years now. I love chocolate and running. I previously worked at Square in San Francisco on build tools, and I'm currently working at Soundcloud in Berlin. I'm the maintainer of Fladle, which some companies here in Berlin use. It's a Gradle plugin for the Firebase test lab. And I'm also working on a new Gradle plugin called Gradle Doctor. So before we get into why Dagger Reflect was built, we need to start with why. Why are we building Dagger Reflect? And to understand that, we need to start with what is dependency injection. So here's a little brief refresher of the history of dependency injection frameworks in Java land. So dependency injection is really just a pattern. Instead of your class creating its objects, those objects are passed into them. This is called the dependency inversion principle. And this makes building very complex classes much easier. So in dependency injection frameworks in the Android world mostly came from historical practices in the Java world. And these frameworks were optimized and built for server frameworks, and they were optimized to solve those constraints. You're running on a server, you have a JVM running, and it's not constantly restarting all the time. So some of these frameworks are Spring. Spring was one of the very first dependency injection frameworks. It worked like this. You had to write a whole bunch of XML configuration. It was no fun. This does exactly the same thing as what the other slide did, but it's a lot more complicated. And then Java 1.5 came along and added annotations. Annotations make dependency injection a lot simpler. Instead of having the configuration in XML, you can add metadata to your classes, such as the add inject annotation, to tell the dependency injection framework how to build that. And Juice was state of the art at the time, given that annotation processors weren't fully developed yet. But then Dagger came around and took those best practices from the server world and brought it to the Android world. One of the constraints in the Android world is that we want a fast startup time. So what Dagger would do is it would run an annotation processor that would construct all the factories at compile time instead of doing it at runtime. And then Dagger 2 came along because we really, really cared about the user's time and app startup time, and it took everything and did it at compile time. And so here's just a basic component in Dagger. And so here you can see a super rough comparison. This is not like comparison. You can't compare runtime and compile time because runtime is in the order of seconds, compiles are in the order of minutes sometimes. So it's just a percentage. Like Juice was doing everything at runtime. Dagger 1 started doing some things at compile time, some things at runtime, and Dagger 2 does almost everything at compile time. So what's the problem with that? Well, as Android developers, if you use Dagger, you start to see builds like this, where you have a 60-second build, and 41 of those seconds are spent in annotation processors. So now we don't care about the user's runtime performance, we care about the developer's compile time performance. And so that's where Dagger Reflect was born. It's a reflection-based implementation of the Dagger dependency injection for fast local builds. So let's take a look at how it works under the hood. So if you're using Dagger and you have your application class, the entry point into the dependency injection is the application component. And this is just a very simple class with the add-component annotation. And you call it from your application class using the factory method or the builder or whatever. This is what the builder would look like, and then you call inject to grab all the objects, blah, 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 blah. This is what your application class looks like. And so this Dagger application component looks very simple. This is obviously a very simple version. But under the hood, Dagger is generating thousands and thousands of lines of code. Here's a little snippet of what ours looks like. And this file is actually 10,000 lines long. This is only 100 of it. And so as you can imagine, generating these 10,000 lines takes some time. And you have to repeat it on every build. But what if we could get rid of that 10,000 lines of generated code and just swap it with 20 lines of code? And that's what Dagger Reflect's code generation does. This 20 lines of code builds the bridge to connect your application with Dagger Reflect. So it points, instead of pointing to all that generated code, it points to the Dagger Reflect runtime. And so you can build a switch, which is what we did, where sometimes you can use the Dagger application component, sometimes you can use the Dagger Reflect application component. And that way, what your app sees is exactly the same. It's just that sometimes you're using the generated code, sometimes you're using reflection. So now let's take a look at how that reflection works. So this is the generated Dagger application component by Dagger Reflect. It's very simple. Obviously this is just a portion of it, but it calls into Dagger Reflect. The Dagger Reflect factory, that is. And the Dagger Reflect factory is a pretty simple class. It looks like this. And it returns a component factory invocation handler. And that's where things might get confusing, but I'll explain what a component factory invocation handler is in a second. It's really just an invocation handler. It's an implementation of an invocation handler. An invocation handler is a Java class in the Reflect package, and what it does is any invocations on this class are proxied through the invocation handler. So this allows you to control any calls on that class using the invocation handler. You can reject calls to the class, you can basically do whatever you want. And this is what Dagger uses, because normally you'd be calling, get me this object, get me that object on the in your Dagger application component, but there is nothing underneath it. So instead, we proxy the calls through the invocation handler, and that calls into a proxy class. A proxy class is, it sounds complicated, but it just implements an interface at runtime. And our proxy class, in our case, is implementing the component interface. So going back to this diagram, the Dagger application component is a proxy class implementation of the application component. And then the component factory invocation handler that we saw earlier is that invocation handler. And this is just a method in the Dagger Reflect library, and it works a little bit like this. So let me break it down. First, it checks the annotation on the class. It makes sure that your class has the component.factory annotation. This is basically the same exact check that Dagger would do when compiling your code, but we have to do it at runtime. Then it checks that the factory is inside of a component class. This is also a check that Dagger would do at compile time. We have to do it at runtime. It wouldn't make sense for you to have a factory class that's not enclosed inside of a component because, well, then it wouldn't know what to build. And then we create the new proxy. This is the proxy class I was just talking about. It proxies the factory. And then we create the invocation handler for that proxy class. And this is just the component class, our Dagger application component. And then we call component scope builder.build component. And what does that do? also pretty much doing the same exact checks that Dagger would do at compile time. First, it checks the annotation, that it has the component annotation on your component. Second, it checks for scoping annotation. So you might have, for example, the singleton annotation on your component class. And then the last thing it does is it creates that component. All right, so that's enough talk about reflection and boring stuff. Let's move on to how Dagger Reflect itself is developed, because I think it has a really interesting Gradle setup in the project that really helps. It really helps development because there's people from all over the world contributing to this project, and there's no lead or direction. But actually, the project's Gradle setup makes it very easy to contribute. So there's 4 pieces to it. There's the Reflect, which is the reflection-based implementation of Dagger, which is the code we just looked at. The second piece to it is the Reflect compiler. This is a very simple piece of this is a very simple annotation processor that just generates the glue to link your code to the reflection-based implementation of Dagger. And then the fun part comes with the integration tests, because everybody loves tests. So what do these integration tests do? They make sure that we're doing the exact same thing that Dagger does with Dagger Reflect. So this project is very unit test driven. And how does that work? So for example, this is one of the tests in the Dagger Reflect project. It's very simple. There's a component, and it calls backend, and then it calls a getter method in that component. And in this case, it's returning a string. Oh, okay, here, this is what the component looks like. So what's interesting about this is the backend. What is the backend? The backend is actually a parameterized test. And what it does is it runs that test with Dagger, compile time Dagger, and Dagger Reflect. And this is just what that enum looks like. The enum has an abstract method called create, and the reflection-based implementation is Dagger Reflect.create. The cogen implementation is Dagger cogen.create. And so if we go back to this parameterized test, basically every test is run with both values in that enum. And that ensures that Dagger and Dagger Reflect work exactly the same way. So if you want to contribute, the best thing to do is to try out Dagger Reflect in your code base, and when something fails, you write a test for it. And that's exactly how I contributed. So in our case, we had nested generic types that were provided by Dagger. So what I did was I wrote a test. It looked exactly like this. And then I called this method ignore reflection backend. Ignore reflection backend is the test assumption. What that does is it just assumes that something is true. In this case, it's assuming that you're not using the reflection-based implementation. So this way you can contribute tests to the project, and then they won't run. And then once you fix that issue, you remove that line. All right, so that's integration tests. There's another part to the test, which is the upstream test. The upstream test is actually a Dagger submodule that contains all of Dagger as a submodule and runs all of the tests that Dagger does on Dagger Reflect. Now, of course, there are a couple things that don't behave exactly the same way in Dagger as in Dagger Reflect. For example, the reusable annotation. There are no guarantees about its behavior in either Dagger or Dagger Reflect, and thus the behavior is different, so that test is ignored using a Gradle test filter. There's also some more complex things and things that don't work yet, and those are also ignored. And as Dagger Reflect starts to match all the features that Dagger has, these tests are introduced back. All right, so how do you use Dagger Reflect? So So there's a couple of steps you have to do if you want to use Dagger Reflect in your project. First thing you have to do is to make sure you use the component builder or component factory in your project. This is also just good general advice. It makes your code safer if you're using component builder or component factory. And what that looks like is in your application component, you just have this factory interface that lets you create your Dagger components. This is similar to what I had earlier in the slides. The second step is to make sure all your Dagger annotations have runtime reflection. So Dagger itself, all the annotations, for example, factory, component, this and that, already have runtime retention in the library. But if, for example, you were using a qualifier annotation in your project, you just have to sneak in that line right there. This is obviously kind of annoying repetitive work, so I created a structural-based search inspection that does exactly that in our project. So anytime you add a new qualifier annotation that doesn't have the runtime retention, you'll get sort of this lint warning and a quick auto fix that'll do it for you. And then the last part is swapping out Dagger for Dagger Reflect. So this is basically changing your dependencies in your project. So if, for example, you have a build.gradle file, it looks like this. You have Dagger and the Dagger annotation processor. You want to create some sort of flag or switch that'll switch between Dagger and Dagger Reflect, in this case a function. And then you'll stick that in your module. So anytime, for example, you want to use any module that uses Dagger and the annotation processor, you'll swap out the Dagger compiler for the Reflect runtime and the Dagger Reflect compiler. It's a really fast compiler. It only takes like 60 milliseconds per build, but you also have to add that. But yeah, you also have to do this in every module. So it gets a little bit annoying when you have a large code base, just something to be aware of. Oh yeah, also if you are using the Dagger Android compiler, also remember to swap that. So yeah, that's a little bit of maintenance work you have to do as well. Oh, and then when you add a new module, you have to stick all that code in there as well. And then we added a new feature to Dagger Reflect, which is lint checks. So you also have to add that. So it's really high maintenance to add Dagger Reflect to your project, but it'd be really a shame if such a high potential project that could save so much time on your builds would be underutilized by the high maintenance costs. And this repetitive task of writing these build scripts is exactly the type of repetitive task that us as developers love to solve. So I'd like to introduce Delect. Delect is the Dagger Reflect Gradle plugin, and it does all that magic for you. All you have to do is apply it to your build, just like so, and magically all your dependencies will be swapped from Dagger to Dagger Reflect. And the way you control it is by adding a Gradle property, which you can simply add it to your build. So that's how we use Dagger Reflect at Soundcloud. And yeah, so how does this plugin work? You may be wondering, how do we take all this fancy code? It's actually a really simple plugin. I'm going to just quickly dive into it, how it works. It runs through all your configurations and all your dependencies in all your projects. And basically what it does is it uses the Gradle's dependency substitution API, and when it finds a dependency that has the group ID Dagger, it adds the Dagger Reflect runtime. And then when it finds the Dagger compiler, it swaps it with the Dagger Reflect compiler. And when it finds the Dagger Android processor, it also swaps it with the Dagger Reflect compiler. So Really simple. But now the question you're all wondering is, how much does this speed up my build? So I did a little micro benchmark in our project. In a clean build and changing a unique Java file would take about 1 minute 54 seconds and 1 minute and 35 seconds with Dagger Reflect. A clean build takes about 30 seconds with Dagger and about 26 seconds with Dagger Reflect. That's after doing the previous build, so it's not really a clean build. A no-op build is basically the same, and making a change to DI is about 1 minute 8 seconds and 1 minute and 1 second with Dagger Reflect. Now these are just micro benchmarks, and it really depends on your project, where you're making the changes, how many things have to be recompiled, compile avoidance, incremental annotation processing, blah, blah, blah. But where Dagger Reflect really shines is when you have builds where you're changing Dagger module configurations. So like the slide I showed earlier, this 60-second build that spent 41 seconds in annotation processing. We also have builds where basically the longer the build in our code base, the more of that time is spent in annotation processors. In this case, a 2 minute 26-second build, which spent 1 minute 6 seconds in annotation processing. And here, another build which was 5 minutes 44 seconds, which spent 3 minutes and 22 seconds in annotation processing. And that 3 minutes 22 seconds would just be, if you look at it, almost all that time, except for 10 seconds, is Dagger. So the longer build, the longer the Dagger time, and the more time you save with Dagger Reflect. But even after looking at, so this is basically a very similar build, and the Dagger Reflect compiler takes 60 milliseconds to run. So it saves you a lot of time in the build. So let's take a look at the current state of the Dagger Reflect project, and just some things to know about using Dagger Reflect. You're going to have a slower startup time in your app because we're using reflection. That being said, it's not as slow as you might expect because it's a bit lazy and it doesn't scan your entire object graph. So you could have broken pieces of your object graph at startup and the app would still work until you reach that broken point. You're going to have different behavior than your production app if you're using Dagger Reflect for local builds, just something to be aware of. And also not all Dagger features are supported yet, but the project is very quickly moving forward to support all those things. Also, the error messages in Dagger Reflect are not as good as those in Dagger, but that's also something that's being actively worked on in Dagger Reflect. And what is the future of Dagger Reflect? Obviously, to match Dagger with features, improve those error messages, also improve runtime performances. Right now, it's not something we're thinking of, but runtime performance could definitely be improved by optimizing the way arrays are created, things like that. There's also potential for Kotlin Dagger Reflect. Uber did this interesting build performance comparison where they showed if you have Java code only generating Java code, it's basically the fastest build you can have. Kotlin generating only Kotlin code is obviously a little bit slower because Kotlin compilation is slower than Java compilation, but mixed Java and Kotlin compilation, generating mixed Kotlin and Java compilation is basically the slowest compilation you can have. So the less mixed sources you have, the faster your builds. And so if Dagger is the only annotation processor you're using and it's generating Java code, and your whole code base is Kotlin, then switching to Dagger Reflect and having a Kotlin-only processor would improve your build speed. So, how do we use this at Soundcloud? Well, this was a long-running side project of mine. We have a small number of devs using it on master as of last week. That is out of date. We've been using it for several months now. Like I said before, it's an opt-in Gradle property. And we're also using a fork of Dagger Reflect where we have extra supported features that, well, they're all in pull requests against the project, but we wanted to use it, so we just forked it and added the features we needed to get it working in our code base. So it was all great and fun when I did this whole Dagger Reflect project. Oh wait, no. So anyways, Dagger Reflect is in Maven Central with version 0.10. And Delect, the Gradle plugin for Dagger Reflect, is also in Maven Central 0.1.0, so try it out in your projects. There's one last thing to note. Even though you look at these builds and you're like, this is taking 5 minutes, 3 of those minutes are in annotation processors. You have to like click this build scan link to see that. And honestly, I'm the only one who looks at these build scan links. They fascinate me, but I know nobody looks at them. So I had an idea, because I'm not going to go around to all the people on my team and be like, hey, I made this thing that makes your build faster. Can you try it? I'm not going to spend talk. I'm not very sociable. I'm not going to talk to everyone on my team or like send people messages. Wouldn't it be great if we just immediately printed the amount of time spent in annotation processing to the console? I asked this in the Gradle Slack, because the build scan plugin does this. And Tony's like, the build scan plugin is not open source. I'm like, that's not a problem. So you open up the build scan plugin, pull apart the jar, you get all this fun code, a.b.b. You figure out what it's doing with the compiled Java data store, which is where it's storing all this annotation processing stuff. Obviously, it's calling the method A when putting it into the event sync, because that makes sense, right? What does A do? A is a cool method. A takes the annotation processor details and puts it in the event sync. So wait a second, this is actually a class in the API of Gradle. Let's steal that information and print it out to the console. So I added this thing, and then pretty soon everyone on the team was starting to use Dagger Reflect, that is, once they see this message in their console. And then you can very clearly see that you're wasting time. So what is the impact overall on local builds? So it's just a benchmark using Gradle Enterprise over a specific week, but all our builds with Dagger Reflect false spent on average of 58 seconds per build, and the builds with Dagger Reflect took an average of 45 seconds. So that's about a 23% decrease in build times on average for our builds. Before I finish, I wanted to thank some people. I want to thank Ricardo for helping me open source this, and my team, obviously, for testing out Dagger Reflect and helping me report issues to the project and building them. Thanks to Soundcloud for letting me work on this in my self-assigned time. And thanks to Jake Wharton, he's really the main builder of the Dagger Reflect project. If you'd like more information on dependency injection in general, you can check out this talk by PY. This is a link to the Dagger Reflect project. This is a link to our Dagger Reflect Gradle plugin, and also the information on dependency injection, the history of Juice and Spring, and that you can find there. And thank you very much.